right, let's discuss the parabola, and know that I'm just holding this with my phone, so it's not very professionally done, but hopefully it will give you what you need to succeed here in this class. First of all, if I would write this down, y equals x squared, you guys already know that this is a parabola. And notice the difference between, we've been working with an ellipse and hyperbola. And remember, both of those were squared, the x and the y. We're here, only one is squared, so that's how you're going to know it's a parabola. So, I mean, just quickly, here's what you guys already know. You know it's x is squared, so you'd be like, oh, it opens up. So it's going to look something like this. Now, in this section, we're going to learn so much more about a parabola, like how is it defined, what makes a parabola, and there's all sorts of special points. Okay, first of all, most of you already probably know that this right here is called the vertex. Everything else we've been working with is the center. There's not really the center of a parabola. So this point, this lowest point right here, is the vertex. Now, there's going to be a point up here somewhere, and we're going to learn how to find it, but it is called the focus. Okay? We haven't ever talked about the focus before when graphing a parabola, but obviously we've been working with that on the ellipse and the hyperbola. The focus is very important, and there's also something else that we have, and that's called this special line down here. And this special line is called the directrix. And again, we'll go over this more in a little bit. You might want to read in your book if you want more definition. All of this is going to be important, okay, because it's what defines a parabola. What a parabola says is that you take any point on the parabola. So let me just pick one right here. And my picture is so off that this looks terrible. But what it says is the distance from this point to the directrix is always the same as the distance from this point to the focus. Okay? Now, obviously, I didn't draw a really quick sketch where it didn't look, the same. But these, whatever this distance is right here, those are always the same. Now, I'm not going to require you on the test or the final to find that distance, but I do want you to realize what it is. So today when we're working, we're going to have to be finding all these little special things. Okay, so let me go over here. And here is the standard equation. This is the standard equation for an ellipse that opens up. Notice you're going to know it opens up because you're already used to that. Whenever you see the x squared, you already know it's a parabola that opens up. This one, you have a y that's squared, so it's going to open to the side or open to the right. All right, let me just do an example for you, and hopefully I'm just going to show you some stuff as we go along. Let me just go ahead and note out some different things. This value in front of the y, this 4p right here, this is always going to be the length of the focal diameter. And you're like, what is that? Well, I'll tell you. That is the width of the parabola through the focus. It's great information. So when you're graphing it, it tells you so much, and we will come back to this definition, okay? Now p, this little value p, is important too. P is the distance you move from the vertex to the focus. So that helps you find it. Vertex, make sure I'm writing this down, to the focus. So we can see so much. And by the way, this vertex happens to be 0, 0. Okay, so this is the standard equation of a parabola that opens up, and let me just say here, at this example, your vertex is the point 0, 0. Same thing here. So everything else applies. My vertex is still 0, 0. Just like we found the center of the ellipse and the hyperbola, we're going to find it the same way. Okay, so for example, let's look at, and I'm looking in your book, I'm going to look at number 24 from your book. So I am on page 700, and I'm going to look at number 24. So hopefully you guys have a book, okay? And it looks right here. Look, you can see my answers. Okay, hopefully we can do this. Okay, so 24, here's what it gives me. We've got the equation x squared equals 12y. here's what I already know from this, just looking at this and what I've told you so far. This is a parabola that's going to open up. The reason I know is because the x value is squared and this is positive. So you guys kind of already know that kind of stuff. So what we're going to do is it's going to ask me the vertex, and my vertex is 0, 0. It also asks over there, it says it wants to know the value of p. Okay, whatever's in front of the y, you're going to take this number, and you're going to take that number and set it equal to 4p. So here, divide both sides by 4, you can see p is 3. That will always be one of the questions, I think, that they always ask you on a test, and if not, I'm always looking for that. Okay, if it would also ask you the length of the focal diameter, which it will here in a little bit, I'm trying to see which one that is. The length of the focal diameter would be 12. Okay, it's always the number. Remember, right out here, the length of the focal diameter is 12. Okay, so let's graph this and see what it looks like. You know what? I got a little graph paper. Isn't this cool that I can use? Okay, so plot your vertex. Here it is, 0, 0. And here's what I know. I know it's going to open up, so I already have this visual right here. But what I'm going to do is I'm going to go up 3 to find my focus. 1, 2, 3. There it is. That right there is my focus. There's only one. On the ellipse and the hyperbola, there was always 2, and that's why it was called the foci. Okay, now to find the directrix, we're going to go the same length down to find the directrix. So P tells me how far to move up to find the focus, and notice I moved up 3. I'm going to go down 3 to find the directrix. So I'm going to go 1, 2, 3. Now the directrix is not a point, it is a line. Okay, so I'm going to go like this. This is not good. I'll have to tape these down, but I'm learning. That's good. So here's my directrix. Notice that is the line right there. That is the line. It's going through the y-axis, so it's the line y equals -3. So right here in my little blank, if they ask me the directrix, it is the line y equals -3. Okay, so it looks like that. Now here's what's cool without plotting any points at all. Since my focal diameter is 12, that means the width of my parabola right here is going to be 12. So that means I would have to go over 6 both ways. Okay, so watch this. I'm going to go over 6. Oops, from the focal diameter. 1, 2, 3, 4, 5, 6. I'm going to put a little dot right here. That would be the end point. 1, 2, 3, 4, 5, 6. So here is my parabola. It's a pretty fat little dude right here. He's going to go up like this. I'm going to extend him, put arrows on him. So there, right there, is my parabola that opens up. Now, I could have found that by plotting points. Okay. The whole goal, notice if I would have put a 3 in here, let's pretend I wanted just to plot points, and I wanted my y value to be 3. Notice I put a 3 in here, I get 12 times 3 is 36, so I would have gotten x squared is 36. Take the square root of both sides, so you would have got x equals plus or minus 6. So this would have been 1 point, and my other point would have been that right there. That right there, you can see I have those points. There's 6, 3, and there is, I moved my graph a little bit, sorry. There's the point -6, 3, okay? Those are the endpoints. They're going to call this, I hate this term, the latus rectum. Those are the endpoints. It's also, I would call it, this is also your focal diameter, because it's the width of your parabola going through the focus, okay? So you can learn so much just from this one thing. Let's try another one. I'm trying to think. I think you have everything by the way. Notice sometimes it's this would be called your axis of symmetry right here because it's the same on the right as it is on the left. It's like a mirror image of each other right there. Okay? All right, let's try number 26. How about? Let me move that. So look in your book at number 26, and this is what it says. It says y squared equals 48x. Okay, here's what I already know by looking at this. Since it's the y value that's squared, I know it's going to open to the right. Okay, this is positive. So here's what I know. I know the vertex is 0, 0. Okay, you can tell that just right here. Nothing's happening to the x or the y. I can tell here the width of my focal diameter. So my focal diameter, that's how wide my parabola is 48. Remember, that's just the value right in front of this x. Right here, remember my focal diameter was 12. It's just the number right in front of the variable. Okay, so that's the width. Then it's going to always ask you, so what's the value of p? So just take this number and set it equal to 4p. So if I divide both sides by 4, notice you get p is 12. Okay, p is important because it tells me the distance to move from the vertex to get to the focus. So if I was going to plot this out real quick, and I'm just going to do this my old-fashioned way and jot this out real quick. I think I can do it better on here. Here's my vertex. I already have this visual. I'm going to do this real light. This is what I kind of know what my parabola looks like right here. It opens to the right. So because that was a quick sketch, I'm going to move over this way 12 to get to my focus. So you could count over 12, or I just know it's going to be over here somewhere, 12 units. So that would be the point 12, 0 to get to my focus. Now if you move over 12 this way to get to your focus, I know I have to move 12 this way to get to my directrix. This is my little. So if I move over 12 this way, I'm over here at negative 12. The directrix is a line. It's always runs perpendicular. Notice right here is my axis of symmetry, right here. Notice it always runs perpendicular, all right? Now, how can I be a little bit more precise? This is what's cool. Remember, your focal diameter is 48. That means the width of my parabola through here is 48. Gosh, half of 48 is 24, so I'd have to go up 24 units. Oh my gosh. This one would be huge, and it wouldn't, there's no way, you know, it's going to fit. But this width right here is 24. I would have to go down 24 right here, because you're going to have this really wide parabola right here. Something like, whoops, I'm looking through my screen, so it doesn't do very good. This width through the focus is the number out front right here, 48. And if it would ask you the endpoints of this, no big deal. I would go 12. I went over 12, and I went up. Do you remember 24? So this should be the point 12, 24. This would be the point 12, negative 24. Okay. I think that's all they wanted to know on number 26. Okay. So let's try something a little bit else. How about, I think 34 was one of them I wanted to go over with you. And maybe I'm going to make this a part 1.